Hi there, and here's a video on collecting like terms in algebra. So this might be something totally new to you, or it might be something where you're just revising something you know already. Either way, the way I tend to do it is I tend to think of them as using the analogy of apples and oranges. So when I'm collecting like terms, I tend to think of if you're in Supermart and you have a job and you've been given a bunch of apples and a bunch of oranges and you need to stack them on the shelf in a supermarket. You want to keep the apples with the apples in their own section, and you want to keep the oranges with the oranges in their own section. You don't have a section where you mix up the apples and the oranges together. So that's what I tend to think of when I'm collecting like terms, keeping oranges with oranges and apples with apples, if you can think of that analogy and bear that in mind as we're going through this. So, since adding or subtracting unlike terms is like sorting apples and oranges, so by sorting, so I crossed out mixing and I changed it to sorting. So by sorting meaning stacking them on a shelf in a supermarket. So since adding or subtracting unlike terms is like sorting apples and oranges, only like terms can be combined. What on earth do we mean by that? So like terms, for example, you can stack the oranges with the oranges, and you can stack the apples with the apples. You don't stack the apples with the oranges. You keep them separate on a shelf in a supermarket. Okay, in algebraic expressions, like terms are terms that have the same variable raised to the same power. So for example, 2x and 3x are like terms because they have the same variable. The variable is x and raised to the same power, x to the power of 1. Doesn't matter that the coefficient is different, so 2x and 3x, that's fine, they're still like terms so long as they have the same variable raised to the same power. Similarly, 7y and 10y are examples of like terms because they have the same variable. They have different coefficients, but that doesn't matter. They have the same variable raised to the same power. So the variable is y and the power is 1. We just don't bother to write the 1. So 2x and 7y are not like terms because they have different variables. Think of that as like apples, like 2 apples and 7 oranges. You would stack them separately on a shelf. But 2 apples and 3 apples you can stack together on a shelf as 5 apples. 7 oranges and 10 oranges you can stack together on a shelf and have 17 oranges. But you wouldn't stack the apples with the oranges. So, for example, if you want to write another little example, you could do something like a squared and 2a squared, or 3a squared, or 4a squared. They're like terms. And why on earth are they like terms? So these, because that's 1a squared and that's 2a squared. Doesn't matter that the coefficients were different. We had 1 and 2. But it has the same letter, same variable, raised to the same power. If I had an a and an a squared, they're not like terms anymore, because although it's the same variable, it's not raised to the same power. Similarly, if I had lowercase a and uppercase a, they're not like terms anymore, because the variable lowercase a is a different variable to an uppercase a. So these 3 are not like terms, and these 3 are not like terms, but this pair are like terms, this pair are like terms, and this pair are like terms. So only the coefficients, the number multiplied by the variable, so 2, 7, 1, in this case 3, 10, 2, only the coefficients of like terms may be different. So these have different coefficients, but it's fine because they have the same variable raised to the same power. So power of 1 and 1, for example. We just don't bother to write the 1. But when it's square or cubed, then we would have the square or the cube. So something like a cubed and a squared, they're not like terms because they don't have the same power, even though they have the same variable. So only the coefficients, the number multiplied by the variable, so the number out the front, the 2 and the 3, of like terms may be different. To combine like terms, just think of it as if you had 2 apples and you added 3 apples, how many apples would you have in total? That's right, you would have 5 apples. So you just kind of combine the coefficients and keep the same variable at the end. So again, it's just like stacking fruit on a shelf. If you had 2 apples in one hand, 3 apples in the other hand, and you stack them on a shelf together, you would have 5 apples. And you were able to combine these two because they both had the same variable raised to the same power. If that was 2x and that was 3x squared, we couldn't combine them. We'd have to leave them as 2x plus 3x squared. and so on. Similarly, if I had a minus here instead, I would have 2x minus 3x. And if I had 2x and I took away 3x, I would have negative x. So the sign is to the left. That means plus 3x. That means plus 2x. So look at these like terms. Let's find all the like terms that can be combined. So v, we've got to look for any other ones that have a v to combine with this one. So the only other one with a v is 16v. So 9v and 16v are like terms. Similarly, x can only be combined. 2x can only be combined with something else that has x. So 6x. Can't be combined with this one because this has 4xy. That's a totally different term. So these two are like terms because they have the exact same variable raised to the same power. 2xy could only be combined with 4xy because they're the only two. And here we have constant terms. Remember, you can have constant terms. So constant terms, none of these have variables, so they're like terms. 3, 8, and 22. So you could color code it, or you can write it out as pairs like this. 2xy and 4xy are like terms. 9b and 16b are like terms. 2x and 6x are like terms. And 3, 22, and 8 are like terms. Now let's do one more page of examples. To combine like terms in any algebraic expression, combine the terms that have the same variable, and so on. So in this case, we've got 5x plus 2y plus 3x plus 7y. So you can almost think of them as 5x plus 3x. You can only combine the apples with the apples and the oranges with the oranges. So if we had 5x's, because that's positive 5x, because there's no negative there, and it's plus 3x because there's a plus here. 5x plus 3x is 8x. That's plus 2y plus 7y. In total, we have 9y. So this would combine to give 8x plus 9y. And notice our answer is an expression. It's just, this is the simplified answer of that. So this is the most simplified version of that expression. Now let's do a few more. Let's try it out. So if we had 4x plus 6 minus 2x plus 9. So think of it, there's 4x. And there's minus 2x. The negative belongs to the 2. That's important. Negative doesn't belong to the 6 or the 9. It belongs to the 2. So that's like 4x, take away 2x. So that'll give you 2x. So remember the sign is to the left. So that's plus 6 plus 9. Notice I underlined the x's in red, underlined the constant terms in green. So that becomes 2x plus 15. Next one. Here we've got 16y, take away 7y. 16y take away 7y is 9y. And plus 9 plus 8x doesn't combine with anything. So you've just got to keep it there. 9y plus 9 plus 8x. So don't delete them, they're still there. Next one. 17 plus 5x plus 10x minus 2x. So because there's 3 x terms, we just add them going from left to right, like according to Bedmass. Go left to right when you're adding and subtracting. So that's positive 5x plus 10x is 15x. 15x take away 2x is 13x, and the plus 17 is still there. It's not wrong if you're at 17 plus 13x, same thing. Same thing with this, you can write 15 plus 2x. You can swap them around so long as you've got the right sign and the right terms there. So this is something to note. The sign to the left of the term tells you whether to add or subtract. So for example, that's why we knew it was minus 2x. We knew this one was minus 2x. We knew this one was minus 7y, because the sign to the left of the term tells you whether to add or subtract. So this one we've got 4x minus 2x plus 6 plus 5x plus 3x. So there's 4x terms here, so let's combine those from left to right. 4x, take away 2x is, have a think, 2x. 2x plus 5x is 7x. 7x plus 3x is 10x. And then we've got plus 6. So it's not wrong if you're at 6 plus 10x instead of 10x plus 6, that's fine. Okay, and that's the end of the lesson. Thank you very much.